Welcome to Matlab video series, Chapter 7, User-Defined Functions and Function Files. A user-defined function is a Matlab program that is created by the user. It can be defined by two methods: saved as a function file, that is an M file, and then used like a built-in function. So we have a function file, we'll give an input and we will get an output. The second method is the anonymous function method. So an anonymous function is a one-line user-defined function that is defined without creating a function file. What are the properties of a function file? Function files are created and edited like script files. How do we get a function file? You have to click on the new page icon on the top left corner of the editor window. The commands of the file can be typed one line after the other, but we have to take care of a certain set of rules. The first executable line in a function file must be the function definition line. So defines the file as a function file, then defines the name of the function and defines the number and order of the input and output arguments. So first word is function. Then we have the list of output arguments typed in brackets. We'll have a unique function name and then the list of input arguments typed inside parentheses. The word function should be typed in lowercase letters and should be the first word in the function definition line. On the screen, the word function appears in blue. The name is typed following the equal sign. The name can be made of letters, digits, and underscore character. But avoid names of the built-in functions and names of variables already defined by the user or predefined by Matlab. Here is a function file. You have function z equals fun of x comma y, which means z is the name of the output and the input variables are x and y. The name of the function is fun. Now we have two outputs here. U is equal to 3 times x, but we'll be using u to evaluate z. So z is equal to u plus 6 times y square. Note the use of a semicolon at the end of the lines. This prevents the values of u and z from being displayed. Note also the use of the array exponentiation operator. This enables the function to accept y as an array. Now let's call this function z equals fun of 3, 7. When you type this in the command window, you get the value z equals 303. So the function uses x equals 3 and y equals 7 to compute z. What if we give the x and y as vectors? So x has got elements from 2 to 4 and y has 7 to 9. So in x there are 3 elements and in y there are 3 elements. So we will get 3 different values for r. A function may have more than one output. These are enclosed in square brackets. Here is another example. The function circle computes the area A and circumference C of a circle given its radius as an input argument. So you have function, then the list of output arguments, which is A and C, the name of the function, which is circle, and the input argument is r. Now we have to give the formulae for these two outputs. A is pi r dot raised to 2, so that we can give r as a vector, and C is 2 times pi times r. And notice that we have used semicolon to suppress the outputs. Now the function is called as follows: in square brackets A, C, equals circle of 4. So it evaluates the value for A and C separately. Here are some examples of function definition lines. First one, where you have one input and one output. Second, here you have brackets are optional for one input, one output. So function and then just the name of the output equals square of side. So side is the input. Two inputs and one output. So function volume underscore box, this is the output, and the name of the function is box, and we have three inputs. Next case where you have one input and two outputs. So that's the case we just discussed earlier. And last case when there is no named output, that is function, square plot, and then side in parenthesis. So most probably it will be a plot. Each function file has its own local variables which are not shared with other functions or with the workspace of the command window and the script files. It is possible, however, to make a variable common, that is recognized, in several different function files and perhaps in the workspace too. This is done by declaring the variable global with the global command, which has the form global and then the name of the variable. Several variables can be declared global by listing them separated with spaces in the global command. For example, global gravity underscore constant, so this stands for that G, and then another where constant is friction coefficient. So there are two global variables here. The variable has to be declared global in every function file that the user wants it to be recognized in. The variable is then common only to these files. The global command must appear before the variable is used. It is recommended to enter the global command at the top of the file. The global command has to be entered in the command window or in a script file for the variable to be recognized in the workspace. The variables can be assigned or reassigned a value in any of the locations in which it is declared common. The use of long descriptive names or all capital letters is recommended for global variables in order to distinguish them from regular variables. Write a function file for the function g of x equals so and so. Write the function such that x can be a vector. Use the function to evaluate g of x for x equal 8 for part A and B when x equals 2, 4, 6, 8, 10. So initially you should click on the top left corner and take a new file. Type in function as the name. The name of the output is G. Give a function name which is fun1 and the input is just x. After that you have to save this file in the same location as your main script file, which is this one. So in the script file, you will just give your input, which is x equal 8 for part A, and then call the function. So g is equal to fun1 of x, and will evaluate the value for you in the command window. Part B, redefine x as a vector and call the function again. So you will get 5 different values. Next example, write a function file that calculates the magnitude and unit vector in the direction of the line that connects 2 points P and Q in space. For the function name and arguments, use mu, which are the two outputs, equal mag unit of P, Q. So we have 2 points. First part is when disconnecting negative 2, 3, 4 to 2, 6, 7, and second part from negative 1, 0, 1 to 1, 0, negative 1. First thing you do is save a function file in the same location as your script file. So for saving a function file, you have to first define the function here in a new window. Function, we are looking for here 3 outputs, v, m, u, equal mag unit of P and Q. So v is the vector from P to Q, which is Q minus P. And m is the magnitude, so we can get that using the norm command, norm of v, and u is the unit vector, which is vector over magnitude, and then you end the function, and later you have to save this file in the same location as your script file. Now when you come to the script file, you define your P and Q and call the function in the same way as you have defined in your function file. So you have part A and part B, and you get the values in your command window. Next method is the anonymous function method. An anonymous function is a simple one-line user-defined function that is defined without creating a separate function file. Anonymous function can be created within a command window, within a script file, or inside a regular user-defined function. The general syntax: you have the name of the function, the @ symbol to denote that you're defining a function using the anonymous function method, then a list of input arguments in parentheses separated with commas, and finally the expression, which is vectorized. Write a user-defined function that evaluates the area and perimeter of the right-angle triangles with sides A3, B4, and C5, and part B when A is 6, B is 8, and C is 10. So first you give a function name, triangle underscore area, equal @ to indicate you are using the anonymous method. Now your inputs are the sides A, B, and C, and since it's a right angle triangle, you know the area, which is half AB. The perimeter is calculated using A plus B plus C. Now define your A, B, and C as vectors, and then you can call the function. So the first output is for the areas, so you give the name for the output, areas, equal, what is the name of the function? Triangle underscore area, and then the list of input arguments, so A, B, C in parentheses. Second, it is perimeters, so the name of the function referring to that is triangle underscore perimeter, PER, of A, B, C, and it will evaluate the two different areas and the two different perimeters. So in this case, we are dealing only with a single script file. We'll work on some questions from chapter 7. Write a user-defined Matlab function for the following math function. The input to the function is theta in radians and the output is r. Write the function such that theta can be a vector. Part A, use the function to calculate r of 3 pi over 4 and r of 7 pi over 4. So first, we'll define the function using the anonymous method. So we give a function name, which is r, equal @ symbol. The input is just in terms of theta, and then you write the vectorized expression for the function. Now we can give a name for the output, so let's call it as r1. r1 is equal to r, which is the name of the function, and the value that we want is 3 pi over 4, so r of 3 pi over 4. Similarly, r2 is equal to the r, which is the name of the function, so r of 7 pi over 4. Let's run this and see the outputs. So we have two different values for r. Part B is use the function to plot, that is a polar plot, r of theta for theta between 0 to 2 pi. So define theta using the linspace command from 0 to 2 pi. Then evaluate the r for the 100 values of theta. So capital R is equal to r of theta. Then we'll use the polar command. So polar of theta comma r, and you can give a title for the plot. So we'll run this and see the output. And that's the polar plot. We'll comment this question for now. Moving on to question number 2. The surface area S of a ring in shape of a torus with an inner radius r and a diameter d is given by this formula. The ring is to be plated with an inner layer of coating. The weight of the coating W can be calculated approximately as W equals gamma S times T, where gamma is the specific weight of the coating material and T is its thickness. Write an anonymous function that calculates the weight of the coating. The function should have 4 input arguments, r, d, t, and gamma. Use the anonymous function to calculate the weight of a gold coating given these values for the input. So you can define all these values first and then give a name for the function, say w equal at the rate. The list of input arguments are r, d, t, and gamma, all separated with commas and enclosed within parentheses. And then the function. Here I have not vectorized the function because we are not looking for multiple values of weight. And put a semicolon after the definition, and we can call the function as w, which is the name of the function, so w of r, d, t, gm, and we'll get the value for the weight, which is 1.3519 times 10 to the negative 4. Question 3. The body fat percentage BFP of a person can be calculated by this formula, where BMI is the body mass index given by this formula, in which W is the weight in pounds and H is the height in inches. Age is the person's age, and gender equal 1 for male and gender equal 0 for female. Write a Matlab user-defined function that calculates the body fat percentage. For the function name and arguments, use BFP equals body fat of W, H, age, and gender. So when you get the question in this format, we are expected to use the function file method. So we have question 3. We'll create a new function file in which function would be the first word, which turns blue in color. The output is just 1, which is BFP, the name of the output. So you need not enclose it within square brackets. The name of the function is body underscore fat, and the input arguments are W, H, age, and gender. So this is the function definition line. Now we have to give the formula for BFP, which is the output. So it is 1.2 times BMI plus 0.23 times age. Now age is all in small, so times age, minus 10.8 times gender, which is GEN, minus 0.54. And always suppress these values within the function file. Now we have something called BMI, so we have to calculate that here, which is 703 times W, which is the weight, divided by H square. And we are done with this function file, so write end and later save it. So click on save. It'll automatically detect the name as body underscore fat.m. Do not change this name. Now this function has to be saved in the same location as your script file c7.m. Now if you try to run this file, we'll get error saying none of these input arguments are listed. So we need to define those here. The input arguments are, for part A, you have age, which is 35, height, which is 6 feet 2 inches, so it would be 34 inches, and the weight is 220 pounds. Now, to call the function, we can use the same format as used in this question. So, come back here, and this is just part A of the question. We could call it as BFP1. So, we can change the name of the output, but we cannot change the name of the function or the name of the inputs. So we have W, H, age, and gender. So gender here for part A is a male. So for male, it is gender equals 1. Now let's run this file. So we get this as the body fat percentage. Similarly, part B, we can copy the same thing. So the age here is 22. The height is 67. The weight is 135. The gender is 0. So note that 1 feet is equal to 12 inches. So when we have 6 feet 2 inches, 6 feet will be equivalent to 72 inches. So in fact the height here was 74. And part B, height is correct, 67. Now let's run this, and we get the body fat percentage to be 29.89% for part B, and for part A it is 30.6019. So this is how we use a new function file. So the function file's name is body_fat, as we can see from the question. Let's try the last question. Question 4. A two-dimensional state of stress at a point in a loaded material is defined by three components of stresses: sigma xx, sigma yy, and tau xy. The maximum and minimum normal stresses, that is the principal stress, at the point sigma max and sigma min, are calculated from the stress components given by this formula. Write a user-defined Matlab function that determines the principal stresses from the stress components. For the function name and arguments, use the following. So the input arguments are the three stress components, and the output arguments are the maximum and minimum stresses. Use the function to determine the principal stresses for the following states of stress. So let's create a new function file here. Function is the first word. We have two outputs, Smax and Smin, equal the function name, which is Prince stress, and the inputs are Sxx, Syy, and Sxy. Now we need to give the formula for the Smax. Smax is given by sxx plus syy divided by 2 plus square root of ssx minus syy divided by 2, the whole thing raised to 2. Plus tau x y square. So let's call that as sx y square and close the brackets for the square root function and suppress that. Next we have s min. It'll be the same but with a change in sign. So instead of positive you will have negative here. And then end. Once we are done with defining the function, we have to click on the save icon. It will automatically detect the name as print stress, which is the name of the file, and make sure it is in the same location as your script file. Now come back here and put in the values for part A, which is sxx is negative 190. syy is 145 and sxy is 110. Now to call the function, you can call it in the same way as it's written here. Let's run this. So there's an error for sxy. So here sxy. So the error was in line 34. Now run this again. You get the two different values for smax and smin. Similarly for part B, we need to just change the values. So sxx would be 14, syy would be negative 15, and sxy would be 8. We can change the name of the outputs. So let's call this as smax2 and smin2. The first one is max1 and smin1. And just run it, and we get the two different values for sxx and smax and smin. That's all for now. Thank you.